Hello everyone, this is our Astro 364 presentation. Today we will be discussing a research paper titled GWORI Interactions Between a Triple Star System and its Circumtriple Disk in Action, published on August 4th, 2020. The main authors of this paper are Jacques B. from the University of Victoria, Canada, and Stefan Kraus from the University of Exeter, United Kingdom. The motivation behind this research is to study systems that are beyond binary and find answers to how planets are formed around multiple stars. Furthermore, they want to solve the mystery behind the misalignment of the dust rings in GWORI. ALMA first observed the GWORI on December 10, 2017. The different apparent shapes of the rings can be the result of either coplanar rings or circular rings with different eccentricities and inclinations. This figure shows a dust continuum map of the GWORI. They have estimated the dust ring masses to be roughly 74, 168, and 245 Earth masses from the inner to the outer rings respectively. This figure shows the relative inclinations of the rings to the ABC binary system. The researchers fit the dust continuum map assuming that there are 3 rings in the disk with Gaussian radial profiles of surface brightness. There are 3 models for this data. The first model is based on an assumption that all disks are circular with different inclinations. The fitting results show that the center of the inner ring is different from the other 2 rings. In the other 2 models, they assume that the outer 2 rings are circular and concentric, and the center of the 2 rings coincide with one of the foci of the inner ring. For Model 2, the center is set free and these are the fitting results. Model 3 has the same assumptions as Model 2, but the center is assumed to coincide with the stellar position provided by Gaia data release. All models show that the 3 rings have different inclinations, but cannot determine the mutual inclinations or the angles between their angular momentum vectors due to unknown direction of orbital motion. The 3 following graphs are obtained via ALMA. The graph on the left is ALMA's self-calibrated dust continuum map. The top right is a zeroth moment map which tells the distribution of the gas. Then we have the first moment map on the bottom right, which normally has a butterfly-shaped pattern for a regular Keplerian rotating disk. However, the twisted pattern seen in this map could be a result of misalignment. These figures show the first moment map of 12 CO emissions from the GWORI modeled as a coplanar and misaligned disk. The team used the parameters of this table to model the GWORI as a misaligned disk with an inner cavity and 3 annuli, while the coplanar disk was modeled with an inclination of 37.9 degrees and a position angle of -5 degrees. This data shows that the coplanar disk model cannot be reproduced by the first observed first moment map of ALMA, so there must be a misalignment in the disk as shown by the figure on the left. In this research, the team successfully obtained the characteristics of GWORI, with the outer rings being the largest ring found in protoplanetary disks, and the 3 stars can be viewed as an ABC binary system. For the dust rings, they identified a misaligned gap between the inner and outer 2 disks. This suggests that there are mechanisms other than torque that may have broken the disks apart. This is a press release associated with the paper, released on September 4, 2020 by National Institutes of Natural Sciences. In general, the press release was consistent with the paper, and it stated the correct values and accurately explained the abnormalities of the system. However, it did not identify the specific methods that the team used to generate the models of the star system. In conclusion, this research contributes to the understanding of planet formations within complex gravitational environments and brings up the question that there may be other companions within the disk, which is possible explanation for the gap between the inner and outer rings. Thank you.